Guys, let's solve this problem. Let's see what the problem asked us. The problem is saying that x is a uniform distribution between -1 and 1, and we are asked to find pi, which is probability x squared is between this interval I by 4 comma I plus 1 by 4 for I is equal to 0, 1, 2, 3 integers. So the question asks us that for which of these I, pi is the highest value. So how to solve this problem? We will use one important distributional aspect of a uniform distribution. That is x. If x is a uniform between 0 and 1, then probability x belongs to any set where a is a subset of this is nothing but the length of a, let's call this, divided by the total length, that is 2. This length is 2, right? So this is the basic idea. You can also derive this easily using integration, but this is always a beautiful aspect of uniform distribution. We will use that, and you will understand why we will use that. Now it's ask us to find probability x squared is equal to this, where x squared belongs to this interval. So it's pi is equal to probability x squared belongs to I by 4 comma I plus 1 by 4. Now there are two ways to do it. One way is to find the distribution of x squared, which demands that you should calculate the PDF of x and then the PDF of x squared using the distribution variation change. There is a result for that. But we will not do that. What we will do is always simplify the problem. We will transfer this x squared probability back to x probability. How to do that? So we will find that for what region of x values x squared will be this. And this is simple, right? Because if this is a parabola, this is x squared distribution, and it's asked in this between this interval, let's call it a and b. So it's asking us that if this is a and this is b, for which values of in the x-axis this will be the x squared will be between a and b. So the answer is simple. The answer is simple. The answer is, if x squared is less than equal to root over b and greater than equal to a, then we will find out that, observe it has one on this side and one on that side, and both has the same length because it's symmetric. So we will just look on the positive hand side. So it means that x is between root a and root b, right? So x is between root a and root b. So what is the length of it in this case? What is the length of this case? So let's rub it off right now. So we have got its root over a minus b. So this is nothing but 2 times, because it's symmetric, one for this side, one for this side, into the length of this, that is root over I plus 1 by 4 minus root over I by 4 divided by, so this is the probability that x squared in this is the length of it, okay, and divided by 2. And you will see that this turns out to be, this 2 cancels, and it turns out to be half times root over 1 I plus 1 minus root over I. And if you rationalize it, you will get half times 1 by, if you rationalize it, you will get root over 1 plus I plus 1 plus root over I. And you can see that as I increases, this decreases, right? So it has the maximum value for I is equal to 0. So the main idea that we use here is this property, that probability x belongs to a set is nothing but the length of that set divided by the entire length, that is 2 here. So it's a very important property for normal distribution. If we didn't use this, we have to find the distribution of x square, which will need additional algebraic work, but that's another good exercise to do if you're interested. It's a beautiful problem. I will see you in the next video.